before actually starting to solve this problem of merging two sorted lists, let's take a step back and look at what are some of the options, because this creates a very interesting perspective as to what's happening with the complexity. So the first approach that would come to your mind, perhaps like a naive approach, is that I can put a nested loop just like I did for the pair sum problem. For every item in A, I can scan through all items of B one by one and find where I need to go. So for example, I can start with A0. I can go and say, look, A0 goes here. Then I go to 2, so I go and compare this with all these items. I go and likewise find for 8, I go and find for 12. So it's almost similar to your pair search problem, the naive approach. I'm creating a nested loop. So I'm going through this list as well as this list. So we can obviously do this, it will work. However, you can imagine that this complexity will be large. It's going to be the order of n square, because that's what we are doing, right? Then you might say that, okay, let's merge the two lists first and then sort them again. So what that means is, well, I take a new list, which is 1, 2, 8, 12, 17, 18, 3, 4, 9, 12, 13. Notice the individual lists were sorted, but the combined list is not, may not be. But I can sort it. However, remember, sorting also is a fairly, let's say, involved operation. We are going to learn about sorting a little bit later. But every sorting, the best sorting algorithms get us to n log n. So yes, we will improve probably from n square to n log n. However, both these approaches can be improved given that the two lists are sorted. So we can build a kind of quick intuition here. Think about it. If I find that my A0 is more than the last item on B, so just an extreme example, if I find that this is the case, in fact, nothing needs to be done. I just need to take my entire list A at the end of B, and that will be the job done, right? However, real life examples may not be so, let's say, well defined. But the reason I bring this up is that the fact that the list is sorted, in fact, gives rise to some very interesting, let's say, possibilities. And this is kind of like the thought process behind the two-pointer algorithm, which we are going to discuss next. Take some visualizations, and we'll find that the two-pointer algorithm will again bring the complexity down of this problem to the say linear scaling, right? So again, we'll go from, let's say, quadratic to n log n to, in fact, n, and hence two-pointer solution really works here quite well. Once again, look at our website www.wipi.in and enjoy programming. Take care. Thank you so much. Bye bye.